All right. Today we're doing the same thing as yesterday, except we're going around different lines. So in this case, we're going to take the same shape, but instead of rotating it around the x-axis, we're going to rotate it around the line y equals -1. So basically, the bottom, so like this point right here, the corresponding point would be there, right? So we'll have a giant circle in the middle, and then that'll go down to all the way down there, whereas this point would be roughly there-ish, and so we'd have a kind of to there, and in there, and in there, and the problem, of course, is going to be, so before I was able to draw the negative part just by making it negative that. Here, if I have negative sine of x between 0 and my bracket's in the wrong spot. I'm gonna need to move it down too, essentially. And negative cosine between 0 and pi over 4. So this is the top part, and that's the bottom part if we were to just cut it in one spot. And it's rotating all the way along the line y equals a -1. So we still have washers. The difference, and so like our general formula is still going to apply, where the volume will be equal to pi times the integral from a to b, whatever that is, 0 to pi over 4 in this case, of big R minus little r squared dx. The differences is going to be in what those radiuses are. So previously, this was the bottom, the axis. The x-axis was the bottom. And so we were just able to use the value of the function as the radius. Now, that's not the bottom, and so we'll get this as the radius. So the value of the function plus 1. Thankfully, it's going to be the same thing here. This distance plus 1 will get you the small radius. So if we go like a equals 0, b equals pi over 4, r, so r is the top, that's the big one, that's cosine plus 1. And then little r will be sine of x. Then we get a volume. We don't need to look at those. But yeah, this is going to be our formula. Use the big radius and the small radius. It's just that we might have to add or subtract something from there. If we wanted to do something like rotate this around the line y equals 2, we could do that as well. Same idea. The differences will be, so now the big radius is to sine. So it would be, so we're looking for this distance right here. And that's going to be 2 minus sine. Got some packages. I don't know if you can hear that. My little one will be 2 minus cosine. So we could change that and see what we get. 2 minus sine 2 minus cosine. And we'll get the same thing, but you know, if we rotated it around, y equals 2 instead of y equals -1.